A person P is 600 meters away from the station. When train is approaching station with 72 km per hour, it blows a whistle of frequency 800 Hz. When 800 meters away from the station, find the frequency heard by the person. Speed of sound equals 340 meter per second. So we have person P, okay? We have person P and we have station, okay, S, and the distance between person and the station is 600 meter, which is given in the question. And when train is approaching station with 72 km per hour, so the train, okay, so this is train, and the train is the source of sound, okay, and is approaching or is moving towards the station, okay, with speed. So I'm writing over here, speed of source, okay, Vs equals 72 km per hour, okay. So let us change this. So Vs equals 72 times 1000 meter divided by 60 times 60 second, okay. So let us simplify this, okay. So we get speed of source equals 20 meter per second. So we have this, clear? And from question, okay, it blows, that is the train blows a whistle of frequency 800 Hz when 800 meter away from the station. And we can see this distance is 800 meter, okay. So when the train, so I'm drawing over here, when the train, okay, so this is train or source is at 800 meter, it blows a whistle of frequency. So at this position, okay, the frequency of whistle or sound emitted by the source is 800 Hz. So I'm writing over here, frequency of whistle or sound emitted by source is F, okay, equals, so we have F equals 800 Hz, okay. So we have this, clear? We have this. Now find the frequency heard by the person. So we are asked to find the apparent frequency, okay. We are asked to find the apparent frequency heard by the person or listener, okay, is F dash, okay. So we are asked to find this, clear? So this is to be determined, okay. We are asked to find this, clear? So the person is hearing, okay, the frequency F dash, and we find, okay, the person is at rest. So it is at rest, therefore, okay, speed of listener or observer or person, okay, in this case V naught equals 0. So we have this. Clear? And from question, speed of sound. Okay. So I'm writing over here. Speed of sound V equals 340 meter per second. So we have this. Clear? We have this. And while solving the numerical related to Doppler's effect, okay, we use this concept. Okay. So I'm writing over here. We use this concept. Clear one? Sound, okay? We always take sound directed from source to observer, whether the source is moving towards observer or is moving away from the observer. We always take sound directed from source to observer. So I'm writing in this way, sound directed from source to observer. Next, direction, okay, from source to observer, okay. Observer is taken as, I'm writing in short, positive direction. Okay. So these are 2 points. Okay. We need to note while solving the numerical problem related to Doppler's effect. We always take sound directed from source to observer, and direction from source to observer is taken as positive direction. So this is to be noted. Okay. Now, we use, okay, this case and generalize it for this problem. Okay. Let's say source is moving towards observer and observer is moving away from the source, and v is the velocity of sound. Okay. And as I said earlier, sound is directed from source to observer. Clear? We have this, and the frequency of sound emitted by the source is f, and the apparent frequency heard by the listener or observer is f dash, and speed of source is vs, and the speed of listener is v naught. And in this case, okay, the apparent frequency heard by the observer or listener is v minus v naught divided by v minus vs. Okay, so I'm writing in this way, and we have f. So we are going to generalize, okay, this expression for different cases occurring in Doppler's effect. So this is to be noted. Okay. Now, in this case, okay, we have observer at rest. Therefore, for v naught equals 0, okay, we have f dash, that is apparent frequency heard by the observer is v by v minus vs, and we have f. Okay? We have this. Now, In this numerical problem, okay, we have train or source, okay, and if the distance between the train and the source, okay, is 800 meter, then, or when the distance between the train or the source from the station is 800 meter, then it emits sound of frequency or whistle of frequency 800 hertz. And we have the observer or listener or person at this position, okay, and we are interested to find this distance, okay. So this distance is, we are going to use this concept, h square equals p square plus b square, okay. So we are going to use this. So we have 800 under root 800 square plus 600 square, okay. So we have this. So on calculating it, okay, we get this distance equals 1000 meter, and let this angle be theta. So we have this. Now we need to note, okay, that we always take sound directed from source to observer. So what we find, okay, since the observer is at this position, okay, and when the train or the source is at this position, okay, then we take sound directed from source to observer, okay, in this direction. So we have sound in this direction, okay. So I'm writing in this way, sound. And since the source is moving along this direction, okay, that is the train is moving towards the station. So it is moving towards the station with speed, or let's say velocity, Vs. So we need to resolve, okay, this velocity, okay, along this direction. Clear? So I'm drawing in this way, okay. Speed of sound is Vs. So we have Vs along this direction. So we need to resolve this Vs since the person or listener is at this position. Therefore, in this direction, okay, we have Vs cos theta. So we have this. So this is to be noted, okay. We have Vs cos theta. So the speed of source along this direction is Vs cos theta. Therefore, we generalize, okay. So as I said earlier, we generalize this case. Therefore, for this problem, okay, the apparent frequency, the formula for apparent frequency, okay, is f dash equals V divided by V minus, and Vs is the speed of sound, and the speed of sound along this direction is Vs cos theta. Okay, so we have this and f. So we are going to use this expression, okay, for finding the apparent frequency or the frequency heard by the person. Okay, so let us discuss once more, okay. When the train, okay, or the source is at this position, okay, we know the speed of source is Vs along this direction, and this angle is theta, and we have person or listener over here. So we need to resolve Vs along this direction. So we need to resolve Vs along this direction. So along this direction, we have Vs cos theta. So this is the component of velocity of source, okay, along this direction. Clear? And as I said earlier, we take sound directly from source to observer. So we have sound along this direction, okay? And the formula for apparent frequency, or the frequency heard by the listener, and we know listener or observer is at rest. So we have this. So this is V by V minus Vs cos theta, okay? So we have this. Let's call it equation 1. Now we need to find cos theta, okay, from this figure, and we know this distance is 1000 meter, okay? So we have this. It is 1000 meter. So cos theta equals 800 meter by 1000 meter. So let us simplify this. Okay. Therefore, cos theta equals 4 by 5. So we have this. Clear? Now, we know, okay, V is 340 meter per second. So I'm writing over here. V is 340 meter per second and Vs is 20 meter per second, okay? 20 meter per second. 20 meter per second, and F is, okay, F is 800 Hertz. So we have this. It is 800 Hertz, okay, and we have cos theta equals 4 by 5, and we are asked to find F dash. So let us find F dash, okay, that is apparent frequency. So F dash equals 340 by 340 minus Vs is 20, okay, times cos theta, and cos theta is 4 by 5, okay, and F is 800, okay. So let's simplify this. So we get 340 by 340 minus 16, okay. So let's simplify this. So we get this. So the frequency heard by the person or observer or listener is 839.5, okay, Hertz. So we have this. So this is the apparent frequency, okay, heard by the listener or observer.